function, then you can see the area under the curve on the left, the green part, is the area on the right, the green part. Everybody agree with that? So if that is the case, you're going to, essentially these two have to be the same. Well, one's negative, but one's positive. It's equidistant on either side of the origin. You can just go from 0 to a and multiply your answer by 2. Why would you want to do that? Because you get to use 0, and 0 usually cancels a whole bunch of stuff. It makes the calculation easier. Okay? Sorry? Okay. So if you can put a 0 into your calculation, you might as well do it because it makes everything easier. All right? So the trick is you will know, or a big hint of when to do it is when the upper bounds and lower bounds are negatives of each other. One's negative, one's positive. So -2 to +2, -1 to +1. That's when you should check, is it even or odd? Okay? If it's even, you go from 0 to a, you multiply your answer by 2. If it's odd, you've already done one of these. So if f of x is odd, then the integral from -a to a before we put the answer, let's actually just draw it. So we'll use our x cubed again. What should my answer be? 0, right? Because these areas are equal, but if you're below the x-axis, what's the value of it? Negative. So when you add them together, you get 0. So if it's an odd function and you're going from -a to +a, the answer is always 0. All right? So that's evens and odds. All right. Now, vertical asymptote. So I'll just give you the graph of this. So what is the integral of 1 over x squared dx? Can you do it? So you can do this. This is an indefinite. We don't have any numbers. So we just go, okay, well we rewrite it like that. And then we add 1 and divide by that number. So we get -1 over -1 plus c, which is -1 over x plus c. Okay? That works, right? Everybody agree with that? Okay. What if I said, I'll do it over here. the integral from 1 to 2 Can you do that? You can, because it's from 1 to 2. I don't know what the scale is here. It's this area here. That's what I'm asking for, right? So we can do that. We know the antiderivative of 1 over x squared is, we just did it, negative 1 over x. We're going to evaluate it between 1 and 2. Plug them in. So you get a half. Yep. That's the next one I'm going to do. So is everybody good with that so far? Okay. So then if I say, basically what Heel said, if I do the integral from negative 1 to positive 1 of, oh, sorry, it's the same function. Shouldn't write it. Of 1 over x squared dx. Okay. So you see the endpoints are one's negative, one's positive. So right away you go, oh, is the function even? Does the function have symmetry with the y-axis? Does it? It does, right? Right here. Flip them like that. It does. It has symmetry. So you'd want to go 2 times the integral from 0 to whatever. But what's in the middle of this? A vertical asymptote, which you never get to, right? And then based on what Torsten was talking about, and I talked a little bit about yesterday, if you're adding those rectangles, when you're at the asymptote, the height is infinite, okay? Because you never actually get to it. So this integral does not exist, all right? So you don't do anything, you just say, did he write D and E? Okay, so just say D and E because of VA at x equals 0. Esmita. What? I just made that up. It could be anything. This could be negative 4 to 1 or negative 3 to 2. It doesn't matter as long as 0 is in the middle. That's if 0 is between here, your asymptote is in there and you can't do it. Okay? So here's the thing. I guarantee he's going to ask you a question like this. I absolutely guarantee it because it's a standard question in first year calculus. All right? What they will do is they'll give you an integral like this. They will say, here's your integral, 1 over 2x minus 1. Solve it. And when you solve that, you can get an answer. Okay? But what's the problem? You have a vertical asymptote, but x is equal to 1/2, which is in the range of this. Okay? So when you get a question where there is a denominator with a variable, ask yourself, where's the vertical asymptote? And is that vertical asymptote in my between my upper and lower bounds? And if it is, all you do is you just go D and E because VA at x equals 1/2. Now, if it's an indefinite integral, like there's no numbers here, you can do it just like this one. Okay? You only get one that doesn't exist when they're asking for a definite integral. Sorry, say that again. No, because you can't get to that point, right? Because if I said, here's your graph, this, and this is at 2, and I said integrate it from 0 to 2, I can't draw a rectangle here, right? Because what height do I go to? Right? It's infinite, so, all right?
What if on the bottom it was x minus 6?
Yeah.
And the vertical asymptote was at 6, but it wasn't between.
Then you can do it. Just like we did on this one. Right? The vertical asymptote's at 0, but that's not in our bounds, so we can get an answer. And visually, you can see that because I can fill that with rectangles. Okay? Does that make sense? Guaranteed there's going to be a question like that on the test. Yeah. The integrals are straightforward. Yeah, it's like 4 or 5 integrals and what's the other question? Newtons, which we'll do in a bit here. Okay. We got that. Okay, let's just do one example. And here we go. So here's your integral. Okay. Polynomial function. So we know, is a polynomial function continuous?
Yeah.
Yes, there's no vertical asymptotes, right? Because we have nothing in the denominator, no variable in the denominator. By definition, that makes it a polynomial function. Okay. So we don't have to worry about vertical asymptotes. What else do you notice? What's jumping out at you? It's 3 and negative 3, which means you want to think of what? And odd functions too with the x, right? Because if there's odd symmetry, like this, then it cancels the 0. So the great thing about polynomials is we can break this up, right? So you can treat them all separate. Is x cubed odd? Yes. So we can rewrite this. I'll just write them all right now quickly. Dx minus 6. Okay. Does everybody agree that I can do that? All right. Go through them. X cubed is odd, right? What do we know about odd functions when you go between positive and negative a values? Bye-bye. Is 3x odd? What type of graph is that? It's a line, right? Is that an odd function? Basically, just look at the, when you're talking about polynomials and you break them up like this, just look at the exponent. Okay? So this is odd, so this is 0. Okay? What about this? 4x squared, odd or even? Even. So I can rewrite that one as 2 times the integral from 0 to 3 of 4x squared. And what about this? Because it's even, I can use this rule right here. Okay? Right? From negative a to a is the same as 0 to a times 2. Because these two areas are the same. So I get that. Is negative 6 or 6 odd or even? You got to think of the x. It's x to the 0, so it's even. Because that's a horizontal line, right? So it's minus 2 times the integrals, oh my gosh, 0 to 3 of 6 dx. So now you can just do those two, and you have zeros in them, which makes your life easier. So it's 2. 4x squared becomes 4x cubed over 3, from 0 to 3. 6x from 0 to 3. I'll let you decipher that. Because really that's where all the practice is. You ready for the answer? $36. So you took something that was this, like doing the integral of this is easy, but plugging these numbers into the antiderivative of this is going to be massive. So if you can simplify it by doing this, and then this quick step here at the bottom, this, I mean, when you put a 0 in, that goes away, that goes away. So you're really just dealing with that and that. That's why you want to do it. Okay? All right. 302, 69 to 73. 75? Don't we do 75? Yeah, 69 to 75 odd. I'm going to put up a, oh my gosh, Newton's method question at 3 o'clock for us to do, and that'll be it. And then I'll give you a integration review sheet. I'm not going to go into this, what he calls the first fundamental theorem. I call the second fundamental theorem. The other thing that he did, the derivative of an integral. We'll do that tomorrow. So I feel like people are. So today is all about definite. And the key's in the classroom. I'll put that in the classroom.
I'm gonna go now.
I'll do it right now.
Thank you, Baldwin.
See you tomorrow.
Sounds good.
This all makes sense?
I think so, yeah.
Okay. Because this is super important. All right. All right. Good luck. Hopefully I'll see you tomorrow. Yeah, it is.